Hi everyone, it's Miss Costa here, and in this video we're going to go through paper 1 for the November 2017 Foundation Edexcel paper. Okay, so to begin with, we've got metric conversions. So it's asking me to change 365 centimeters into meters. So it's helpful to just write down what the conversion is. I know that 1 meter is 100 centimeters. So that means that to get from meters to centimeters, I would multiply by 100. And to get from centimeters to meters, I would divide by 100. So I know that I need to change 365 centimeters into meters. So I'm going from centimeters to meters. So I'm going to need to divide by 100. So 365 divided by 100. Now, this is a non-calculator paper. So if you struggle dividing by tens and hundreds, then you could write it as a fraction. Or if we did dividing by 100, I know that 100 can be created by 10 times 10. So that is the same as dividing by 10 and then dividing by 10 again. So dividing by 10, if my number is a full number with no zeros in it, then I would, oh, what just happened there? Then I would just put 1 decimal point in. Okay, so I'm dividing by 10, I'm making it a tenth of the size. So 365 divided by 10 would be 36.5. But if I then divided by 100, I'm moving everything. So that would become 3.65. The best way to think about it is that 300 divided by 100 would be 3. So therefore you know that 365 would be 3 point something. So that would be centimeters into meters. Then I need to change 2.7 kilograms into grams. And I know the conversion I should know is that 1 kilogram is 1,000 grams. So to go from kilograms to grams, I would multiply by 1,000. And to go from grams into kilograms, I would divide by 1,000. So I'm going from kilograms into grams. So I'm going to multiply by 1,000. So 2.7 times by 1,000. And just like before, the best way to do this is to think to yourself, okay, what would 2 times 1,000 be? I know that 2 times 1,000 would be 2,000. So I know that's the place value it's going to be, but it's 2.7, so it would be 2,700. When you multiply, again, you could do it by 10 by 10. So if you multiplied it by 10, that would become 27. If you then multiplied by 10 again, it would become 270, and multiplied it by 10 again. So you can do it step by step. But yes, 2,700. Next, I've got a BIDMAS. So with BIDMAS, it's helpful to think of it like a pyramid. So brackets is at the top, then indices, then you've got division or multiplication. So division and multiplication are on the same level of the pyramid, but you do whichever one comes first. And then you do addition or subtraction. So brackets is first, then indices, so something like x squared or the square root of x, then division or multiplication, and then finally addition or subtraction. So you look at what you've got in front of you and you're like, okay, there's no brackets here, there's no indices. So the first thing I'm going to do is the multiplication, which is over here. So I just rewrite that, and I know I'm going to do the multiplication bit first. So 7 times 10 is 70. So you keep everything in the exact same place that it is in the calculation. Then you do 2 plus 70, which is 72. Okay, next we've got solving an equation. So when I'm solving, what I want to do is essentially get it in the form where the variable, so the letter, is by itself on one side so that I can figure out what its value is. Now there's a few ways we can do this. If we think about it as a function machine, so I know that y is over here. I know that this line here means divide. So I know that y is being divided by 4. So if I put y into a function machine, the first thing that would happen is that I'm going to divide it by 4. And what comes out, the output, would be 10.5. So to figure out what y must have been, I can do the inverse, go backwards through the function machine. So I start with 10.5 and I have to do the opposite. So the opposite or the inverse of dividing by 4 is timesing by 4. And that would tell me what y is. So I need to do 10.5 times by 4. Now 10.5 times by 4, I could break it up. So 10.5 is the same as 10 plus 0.5. So I could do 10 times by 4 and then 0.5 times by 4. So 10 times 4 is 40. 0.5 times 4, remember that multiplication is the same as repeated addition. So 0.5 times by 4 is the same as 0.5 plus 0.5 plus 0.5 plus 0.5. So it might be easier to just add it together. So 0.5 plus 0.5 is 1, plus another 1 would be 2. So y must be 42. So that is the function machine method. The other way is, once you understand how function machines work, you know that y is being divided by 4 and it gives you 10.5. This means divide, so the inverse would be to times both sides by 4, so you know that y is 10.5 times by 4, and then you do the calculation. 10 times 4 is 40, 0.5 times 4 is 42. But yes, there's loads of ways to do this. You just need to choose the method that works best for you. Next, we've got 4 numbers. So we've got -9, -2, 2, and 9. And I need to write one of these numbers in each box to make a correct calculation. So I know that my end result is -7. So if you just think of your number line, you've got 0, -1, -2, -3, -4, -5, -6, -7. And whenever you are going up the number line, that is when you add. So when you add, you go up the number line, and when you subtract, you're going down the number line. So I know that I want to reach -7, and I've got an add in between. So I probably want to start with -9. Now this is where it gets a little bit tricky. So I have 2 options. I can either add -2 or 2, and if you're a bit confused, then just try both. So -9 plus -2. Whenever I've got 2 signs next to each other, I always want to rewrite it as one sign. And a way to think about it is when you're adding negative numbers. So if you just think of like this nice little bowl of soup, okay? And it's a bit too hot, so you add some ice cubes into the soup. So adding a negative, the net result of that would be to bring the temperature of the soup down. It would cool it down. That's why we put ice cubes in our drinks. So when you're adding a negative, it's the same as just subtracting, because you're making it cooler. So -9 minus 2 is going to give me -11. So I know it's not going to be that. So let's try -9 plus 2. So -9 plus 2. And remember, if I started at -9, I'd just be just down here. And when I add, I go up the number line. So I'd start at -9 and I'd go up 1, 2. So that would take me to -7. So -9 plus 2 would be the calculation that I want to have. Next, I've got the first 4 terms of a number sequence are 2, 5, 11, and 23. The rule to continue the sequence is multiply the previous term by 2, okay? So multiply the previous term by 2 and then add 1. I need to work out the 5th term of the sequence. So this is the first term, this is the second, this is the third, and this is the 4th. The 5th is going to be the one after it. So what do I have to do? Multiply the previous term by 2. So I'm going to need to do 23 times by 2 and then add 1. So 23 times by 2. Again, repeated addition is the same as multiplication, so I could just add it if I wanted to. 3 plus 3 is 6, 2 plus 2 is 4. So that would give me 46 plus 1, which is 47. So that would be the 5th term of the sequence. Next, I have a diagram which shows 5 straight rods. The first rod is A minus 1. The next 3 rods all have a length of A, and the final rod has a length of A plus 4. Whenever we use algebra, it's just because we don't necessarily know the length of something or the price of something, but we know what its price is in comparison to other things. So here, I'm told that all measurements are in centimeters and the total length of the 5 rods is L. So this plus this plus this plus this plus this must equal L. And I need to find a formula for L in terms of A. Okay, so all of these rods added together equal L. So let's just write that first. So L must equal A take 1 plus A plus A plus A plus A plus 4, because all of these rods need to be accounted for. So now that I've accounted for them, this is the long formula. And now I want to write my formula as simply as possible. So whenever I am simplifying terms or collecting like terms, I look for all of the letters that are the same letter and also the same power. Then I can collect them. You can imagine it like a sieve, and all of the A's fall through, and you can just count up how many you have. So you've got A plus A plus A plus A plus A. So that's 1, 2, 3, 4, 5 A's in total. And then you've got minus 1 plus 4, or you could say 4 minus 1, which is positive 3. So that would be how you'd write your formula and how you would simplify it. Okay, so now I need to read some coordinates, and whenever I read coordinates, I always go along the corridor and up the stairs. So I always read the X coordinate first and then the Y coordinate. So over here, I'm going to start at 0, 0, and I'm going to go along the corridor to where the coordinate is. So it's over here at 6. So my X coordinate is 6, and then it goes down to negative 2. So that would be 6, negative 2. I could draw that line there if I wanted to, but sometimes you just get to the point where you can look at the coordinate. You know, the X coordinate is here, the Y coordinate is there. So it's 6, negative 2. Next, I need to plot the point with the coordinates 2, 9. So again, I go along the corridor to 2. So the X coordinate is 2, the Y coordinate is 9. So along the corridor to 2, and then up the stairs to 9. So I'd plot it here at 2, 9, and label this point B. Next, it says, does B lie on the straight line with equation y equals 4x plus 1? So B was the coordinate 2, 9, so let's just replot it. And to check if a coordinate lies on a line, so like I said, every coordinate, it's the X coordinate first, then the Y coordinate. So for the coordinate 2, 9, X is equal to 2. So the X coordinate is 2 and the Y coordinate is 9. So in this straight line with the equation y equals 4x plus 1, 9 must equal 4 times by x, which is 2, plus 1. So we can substitute that in. So 9 equals 4 times 2 plus 1. Is that correct? If that is correct and that works, then yes, it does lie on the line. So does 9 equal 4 times 2, which is 8, plus 1? Yes, 9 equals 9. So yes, it does. And the working is obviously all of this. Another thing you could have done is just substituted one coordinate in. So we could have just substituted x in and said y equals 4 times 2 plus 1. So y equals 8 plus 1, y equals 9. And I know the y coordinate is 9, so I could have done it that way too. On the grid, draw the line with equation x equals 2. Okay, so generally the quick little shortcut method is that all of your vertical lines like this are going to be x equals, and all of your horizontal lines like this are going to be y equals. And the reason for that is because if I look at where x is minus 2, so this is where along the x-axis x is minus 2, but this coordinate here, that would be minus 2, 1. This coordinate here would be minus 2, 2. This coordinate here would be minus 2, 3. This coordinate here would be minus 2, 4. So each of the coordinates on this line, each of the x coordinates on this line would be negative 2. And that's why all of the vertical lines would be x equals, because they cross the x-axis at that point, which means that on that line, every x coordinate is going to be negative 2. Next, I'm told that the length of a rectangle is twice as long as the width of the rectangle, and that the area of the rectangle is 32 centimeters squared. Okay, so I know that I've got my width and that the length is twice as long as the width. So as an expression, I could say that the width is just W and the length is going to be 2 times by the width. And if I know that the width is W, I could say the length is 2 times W, which would simplify to 2W, because whenever you write a number and a letter in algebra, you don't write the multiplication sign. So 2W times by W must make, how do we work out area? Area is simply base times by height for a rectangle. So each dimension multiplied by the other. So I've got W times by 2W is going to give me my area. So when I'm multiplying indices, I could just write it out like this, W times 2 times by W. Anything multiplied by itself, so W times by W is going to become W squared. So it's going to be W squared times by 2, which would simplify to 2W squared. So I know that the area of this rectangle is 2W squared and that the area total is 32 centimetres. So what I could do is try and figure that out. So what does this mean? It means 2 times W squared. So I divide both sides by 2 first. So W squared equals 16. And then W squared, I'd have to do the square root of both sides because that's the inverse of squaring. So W would be the square root of 16 and W would be 4. So if W is 4, 2W, 2 lots of 4 is going to be 8. Now, you could have also done this by trial and error. You could have just thought, okay, what are the factors of 32? You could have said, okay, I know I could do 1 times 32, 2 times 16, 4 times 8, and so forth. And you could have then thought, are any of these doubles of each other? You could have done it that way. I'm just showing you the algebraic way as well. So I know that it's a width of 4, so 1, 2, 3, 4, and a length of 8. 1, 2, 3, 4, 5, 6, 7, 8. So then I just draw my rectangle like that. Next, I've got a division problem. So Jackie wants to work out 3,480 divided by 5. And whenever we've got something like this, where it asks us to show something or find a mistake, it's helpful to actually do the calculation yourself so that you see what your thought process is and how it differs to this person. So she knows that 3,480 divided by 10 is 348. So she writes 3,480 divided by 5 is 174 because 10 divided by 5 is 2. So therefore 348 divided by 2 is 174. Okay, so when you're dividing 3,480 divided by 10, yes, that becomes 348 because you can divide the numerator by 10 and the denominator by 10, so you're just left with 348. But if you were to divide by 5, you're essentially, if we take it back to a simpler number, so if we did 20, okay, so like a length of 20 divided by 10 and then a length of 20 divided by 5. When I'm dividing by 10, I'm splitting it into 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal pieces. So 20 divided by 10 is going to be 2, but 20 divided by 5 is going to be 4. So when you're dividing by 5, your answer is actually going to be double the answer of what you got when you divide by 10. So the mistake that she made is that even though 10 divided by 5 is 2, when you're dividing by 10, you're dividing by more parts, so your answer is smaller. When you're dividing by 5, you're dividing by less parts, so your answer is bigger. So she writes 3480 equals this because 10 divided by 5 is 2 and 348 divided by 2 is 174. She's misunderstood how division works. This is actually quite a tricky question to try and explain. I haven't actually looked at the mark scheme to see what they want from you. I would have just done the division myself. So 3,480 divided by 5. How many times does 5 go into 3? 0, remainder 3. How many times does 5 go into 34? 6, remainder 4. How many times does 5 go into 48? 9, remainder 3. How many times does 5 go into 30? Is 6. So 3480 divided by 5 is 696. I'm actually confused as to what, for 1 mark, they want from you, because it's quite a lengthy explanation for a question 9. But if you show what the division is, the mistake she made is assuming that if she breaks the division into dividing by 10, I'm going to come back to this. Okay, so the mark scheme says that she should have multiplied 348 by 2 instead of dividing. But I think that's just quite a hard question for question 9 on foundation in terms of the conceptual reasoning. Maybe I'm being dim, but yeah, I mean, if you worked it out for yourself, you know that it's 696. 348 is half of 696. So what she tried to do is she knows that 10 divided by 5 is 2, but dividing by 10 gives you half of the answer that dividing by 5 would give you. So you actually need to double it. I'd be interested to know how many people got that. Okay, anyway, next question. Jake and Sarah each played a computer game 6 times. Their scores for each game are shown below. Who had the most consistent scores, Jake or Sarah? So consistent means like bunched together. So the smallest range, essentially. So let's work out the range for Jake. So the largest value is 12 and the smallest value is 8. So 12 take away 8 is 4. And then for Sarah, smallest value is 2, largest value is 14. So the range for Sarah is 14 take 2, which is 12. So I would say that Jake had the most consistent scores, as his range was a lot lower. So it means that all of his scores were within like 4 marks or whatever, 4 points of each other. Where Sarah, she may have done really well and got 14, which is higher than any of Jake's scores, but she also did quite badly and got 2 and 4. So she either does really well or really badly, whereas Jake is consistently hovering between 8 and 12. So that's what consistent means, like the smallest range. And that's how we deal with distribution. Then I'm told that Jake played a different game 20 times. The stem and leaf diagram shows information about his scores. Jake said his modal score was 6 points because 6 occurs most often in the diagram. Okay, so modal references the mode. It's the plural for the mode, and the mode means the most common value. So he's correct in that 6 occurs most often in the diagram. However, he doesn't know how to read a stem and leaf diagram, because over here, if we look at the key, 1 and then this little line 2 represents 12 points. So on the stem and leaf, this would be 9, this would be 12, 13, 13, 14, 15, 25, 26, 26, 26, 26, 27. So that's why we bunch. With a stem and leaf, you've got your trunk or your branch. Different people call it different leaves, or I guess your stem, that makes more sense. And that's like the consistent thing. Normally it's tens, and then you've got your units as your leaves. Sometimes it's the hundreds. It just depends what your data is saying. Sometimes it's decimal points as well. But your stem is like the key part, which in this case is the tens, and your leaves are the other part. So no, he is incorrect. The modal score was, so now that I know that each of these scores, what they mean, that would have been 9, that would have been 12, 13, 13, 14, 15. This would have been 25, 26, 26, 26, 26, 27. So just by looking at that, I think we have a clear winner. We've got 26, appears 4 times. No other number appears more than that. So the modal score was 26. So he's close, but he just doesn't know how to read a stem and leaf diagram. Okay, there are 30 children in a nursery school. At least one adult is needed for every 8 children in the nursery. Work out the least number of adults needed in the nursery. Okay, so for 8 children, I'm going to need 1 adult. If I then add on another 8, that's 16. So for 16 children, I'm going to need 2 adults. If I add on another 8 children, that's 24. And I would need 3 adults. Now, anything above 24, I'm going to need at least 4 adults for, because at least 1 adult is needed for every 8 children. So the first 8 children, 1, 2, 3, 4, 5, 6, 7, 8, they are happy to be with 1 adult, which is represented by a square. But if I had 9 children, I would need 2 adults, because anything over 8 requires another adult. So therefore, the next kind of bunch of children would be 32, and up to 32 children would require 4 adults. So even though 30 is less than 32, I still need 4 adults, because anything above 24 counts as more than like 3 portions of children. So the least number of adults would be 4 adults. I'm then told that 2 more children join this nursery. Does this mean that more adults are needed in this nursery? No, as 32 children are still covered by 4 adults. If it was 33, then more adults would be needed. But because 32 is still covered by 4 adults, I don't need any more adults. Next, I've got a question about Emma. She has 45 rabbits. 30 of the rabbits are male. Okay, so this is how a two-way table works. You've got your columns. So this is your column for male. And you know that 30 of the rabbits are male. So in total, I know that 30 of these rabbits are male. Next piece of information I'm told is that 8 of the female rabbits have short hair. So out of the female rabbits, I don't know the total, but I know that 8 of them have short hair. Oh, it's just deleted. Okay, so 8 of the female rabbits have short hair, so I can fill that in here. And 12 of the rabbits with long hair are male. So the long hair, 12 of them are male. Use the information to complete the two-way table. So with a two-way table, your 2 columns add up to the total, and your 2 rows as well add up to the total. So I know that 12 plus 18 gives me 30. And then I know that 18 plus 8 would give me 26, so I can fill that in. And I also know that in total she has 45 rabbits, so I can put that over here. Now, I know if she has 45 rabbits, that means that 45 take 30 gives me 15, so I can fill this in. And 15 take 8 gives me 7. And then 12 plus 7 is 19. To double check that everything's correct, 19 plus 26 gives me 45, and 30 plus 15 gives me 45. Now, one of Emma's rabbits is chosen at random. Write down the probability that this rabbit is a female with short hair. So a female with short hair that would be 8 out of the total, which is 45. Next, I'm told that the total surface area of a cube is 294 centimeters squared. So that means that a cube is a 3-dimensional shape and it has 6 faces. So it has the front, the back, the top, the bottom, the side, and this side over there. So I've got 6 faces. I can draw it in a net, and they are all going to be identical because a cube, it's a 3-dimensional square. So I know that whatever this length is, this length would be the same as well. So I can just say that that would be x, and therefore the area would be x squared. And I've got 6 of these faces, so I have 6 lots of x squared must equal the total surface area of 294 centimeters squared. So step 1 would be, what does 6x squared actually mean? It means 6 times by x squared. So my first step would be to divide both sides by 6. So let's use the bus stop method. So 294 divided by 6. How many times does 6 go into 2? 0, remainder 2. 6 goes into 29, 4. So 6, 12, 18, 24. So it goes into it 4 times with a remainder of 5, and 6 goes into 54 9 times. So I know that x squared must be 49. And then I need to do the square root because that's the inverse of squaring. So x is going to be the square root of 49, and the square root of 49 is 7. So now I know that each side of the cube has a length of 7. To work out the volume of the cube, all I do is I know that this length is going to be 7, this length is going to be 7, and so is this length. And to work out the volume, I just work out the area of the front face, which is 7 times 7, and then I multiply that by the length. So 7 times 7 is 49, and then 49 times by 7, 7 times 9 is 63, and 7 times 4 is 28. 28 plus 6 gives me 34, so that would be 343 centimeters cubed. Next, I'm told that here are 2 fractions. Work out which of the fractions is closer to 1. Okay, so with fractions, I know that this line here means divide, so I can do 7 divided by 5 and 5 divided by 7. So how many times does 5 go into 7? Once, with a remainder of 2. Whenever I run out of numbers, I put a decimal point and I just put a bunch of zeros there. So how many times does 5 go into 20? 4 times, and that's it. So 7 divided by 5 is 1.4, and then 5 divided by 7, how many times does 7 go into 5? 0 times. I've run out of numbers, so I put a decimal point and a bunch of zeros, and my remainder would be 5. And how many times does 7 go into 50? Well, 7 times 7 is 49, so that would be a remainder of 1. 7s into 10 go once, remainder 3. 7s into 30 go 4, remainder 2. 7s into 20 go twice, remainder 6. And you can see that this is going to be quite a long decimal, but I don't really need to know the next few digits because 1.4 is 0.4 away from 1, and then 0.7142. So if I just rounded that to, well, if I rounded it to 7.2, 1 take away 0.72 is 0.28 away from 1. So therefore 5/7 is closer to 1. Next, I'm told that there are only red buttons, yellow buttons, and orange buttons in a jar. The number of red buttons to the number of yellow buttons and the number of orange buttons are in the ratio 7 to 4 to 9. So I could visualize that. So 1, 2, 3, 4, 5, 6, 7 to 1, 2, 3, 4 to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I need to work out what percentage of the buttons in the jar are orange. So how many parts do I have in total? 7 plus 4 plus 9, or 7 plus 9 is 16, plus 4 is 20. So there's 20 parts in total. And the orange, there's 9 out of 20 parts that are orange. So I need to turn this into a percentage, and a percentage is essentially just a fraction out of 100. Percent just means out of 100. So what have I done to my denominator? What have I multiplied 20 by to turn it into 100? I've multiplied it by 5. So I do the same to 9. 9 times 5 is 45. And 45 over 100 is 45%. Next, I'm told that Veronica wants to buy 35 t-shirts. Each t-shirt costs £5.80. She does the calculation 40 times 6 is 240 to estimate the cost of 35 t-shirts. Explain how her calculation shows the actual cost will be less than 240. Well, she's rounded 35. She's rounded it up to 40. So she has calculated the cost of more than 35 t-shirts, and she has also rounded £5.80 up to £6. So she has calculated more than the cost of each t-shirt. So because she has rounded each value up, that means that the cost is going to be higher, and also the amount of t-shirts she's calculated is going to be higher. So because she's rounded both values up, the cost must be less than 240. If you wanted to be super certain, you could work out what 35 times by 6 would be, because then you've just worked out, you've just rounded one thing up, and 35 times by 6, we could break that down into 35 times by 2 times by 3. So 35 times by 2 is 70. 70 times 3 is 210. So even 210 is going to be less than the actual cost because I've rounded the cost up. Okay, there's a special offer. T-shirts are £5.80 each. Buy 30 or more t-shirts and get 10% off the total cost. So work out the actual cost of buying 35 t-shirts using the special offer. Okay, so 30 times by £5.80. Once again, I could break 30 down into 3 times by 10. So that just might make my calculation a little bit easier. So 10 times £5.80 would be £58. And then I just have to do 58 times by 3. So 3 times 8 is 24. 3 times 5 is 15. Add 2 is 174. So 3 times 58 is £174. But now, because I've bought more than 30 t-shirts, I get 10% off the total cost. So 10% of 174, I just divide it by 10. That's the shortcut to work out 10%. So 10% of 174 would be £17.40. And then if I subtract that from 174, so I could just line up all my points, £17.40. So 0 take 0 is 0. 0 take 4 you can't do, so you borrow a 10 from here. 10 take 4 is 6. 3 take 7, once again you can't do, so that becomes 6. And 13 take away 7 is 6. 6 take 1 is 5. And 1 take 0 is 1. So the actual cost would be £156.60. Now I'm told that there are 3 cards in box A and 3 cards in box B, and there is a number on each card. Ryan takes at random a card from box A and a card from box B. He adds together the numbers on the 2 cards to get a total score. Work out the probability that the total score is an odd number. Okay, so I could, if I chose 3, I could add it like, this is what I choose from box A. I have 3 options. I could add it to 9, 2 or 3. So 3 plus 9, 3 plus 2, 3 plus 3. 3 plus 9 is 14. No, sorry. 3 plus 9 is 12. 3 plus 2 is 5, and 3 plus 3 is 6. So that is my first option. Next, I could choose 4 from the first box. So 4 plus 9, or I could do 4 plus 2, or I could do 4 plus 3. So 4 plus 9 is 13, 4 plus 2 is 6, and 4 plus 3 is 7. Finally, I could choose 5. So if I chose 5, I could also combine that with everything else. So 5 plus 9 is 14, 5 plus 2 is 7, and 5 plus 3 is 8. Now I need to work out the probability that the total score is an odd number. So how many possible combinations do I have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability is going to be out of 9. And how many of these are odd numbers? 5, 13, 7, and 7. So 4 out of my 9 options would be an odd number. Next, I'm told that Harry, Regan and Keelan share £450 in the ratio. So Harry to Regan to Keelan. They share it in the ratio 2 to 1, 2, 3, 4, 5 to 1, 2, 3. So they have in total shared £450 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So if I did 450 divided by 10, I could figure out what the value of 1 part is. 450 divided by 10 is 45. So 1 part is worth £45. So each of these parts are worth £45. And then I need to work out how much Keelan gets. Keelan gets 3 of these parts. So I need to do 45 times by 3. So 3 times 5 is 15. 3 times 4 is 12. Add the 1 is 13. So Keelan gets £135. Next, I'm told that here is a list of ingredients for making 16 flapjacks, and that Jenny wants to make 24 flapjacks. Work out how much of each ingredient she needs. So this is where it's really good to think about multiples. So 16 and 24 are both in, well, they're in the 4 times tables, the 2 times tables, and the 8 times tables. So I'm always going to try and look for the highest common factor. So I know I've got 8, 16, and 24. So if I just halved 16, then I could figure out what the ingredients needed for 8 flapjacks would be. So half that is 60 grams butter, 70 grams sugar, 125 grams of oats, and 1 tablespoon of syrup. So I know that 8 times by 3 gives me 24. So I'm just going to multiply each of these values by 3, and then I can figure out how much of each ingredient I need. So 60 times 3 is 180 grams of butter. 70 times 3 is 210 grams of sugar. 125 times by 3. So if you need to, you can always just actually do the multiplications if you can't do it mentally. So 3 times 5 is 15. 3 times 2 is 6. Add the 1 is 7. 3 times 1 is 3. So that'll be 375 grams of oats, and then 3 tablespoons of syrup. So that's how I could work that out. You could also have divided by 16 and then multiplied by 24, but that's a little bit trickier. So normally it's the best thing to do is to find, what's the highest common factor of both of these values, and then use that to help you. So 180 grams, 210, 375, and 3. Amy and Josh use a calculator to work out 595 divided by 4.08 squared plus 5.3. Amy's answer is 27.1115. Josh's answer is 271.115. One of these answers is correct. Use approximations to find out which answer is correct. So it's always really good to actually just estimate what the answer to your calculation would be, because calculators, sometimes you enter things wrong and they just tell you the wrong thing. So 595, I could round to 600. When you approximate or estimate, generally you should round to one significant figure. So 595 to one significant figure is 600. 4.08 I would round to 4, and 5.3 I would round to 5. So 600 divided by 4 squared. 4 squared is 16. 16 plus 5 is 21. So 600 divided by 21. Now you could use this, or you could then also approximate to turn it into, that would be approximately 600 divided by 20. So then we could just divide by 10, which would be 60 over 2, which is 30. So if I know that the answer should be roughly 30, I know that Amy is correct, because in terms of place value, 30 is a lot closer to 27 than 271.115. Now I need to work out this calculation and give my answer in standard form. So whenever I'm multiplying decimals, what I want to do is turn them into whole numbers. So 0.06, if I times that by 100, that would give me 6. 0.0003, if I times that by 10, 100, 1,000, 10,000, that would give me 3. So 6 times 3 is 18. Now 0.06 times by 0.0003, what I want to do is either I then divide my calculation by 100 and then 10,000, or you can just think, how many digits are after the decimal point in my calculation? So I've got 1, 2, 3, 4, 5, 6 digits after the decimal point in my calculation. So therefore in my answer, I'm going to need to have 1, 2, 3, 4, 5, 6 digits after the decimal point. Now I know 6 times 3 is 18, so I'm going to fill that out at the end, and everything else I'm going to turn to zeros, and that has the same effect as dividing by 100 and then by 10,000. So I then have 0.000018 divided by 0.01. So I then have to do division, and with decimals there's a little trick as well. If we just think about something pretty easy, 6 divided by 2 is 3. If I multiplied that by 10, 60 divided by 20, that is also 3. If I did it again, so 600 divided by 200, that is also 3. So it follows that if I divided by 10 instead, 0.6 divided by 0.2 would also be 3. So with dividing decimals, it's slightly different. So I've got 0.123456 divided by 0.01. So what I want to do is multiply everything until I can get a value that is not a decimal. So if I multiply by 10 and then 10 again, so 100 in total, well, let's do it step by step. So multiply it by 10, that would be 1, 2, 3 zeros, 1, 8 divided by 0.1. If I multiply by 10 again, that would be 0.0018 divided by 1. Now, because with division, when I multiply or divide both parts of the calculation by a power of 10, I end up by the same answer. I know that 0.018 divided by 1 is going to give me the same value as this calculation, and anything divided by 1 is just itself. So that would be 0.0018. And to write it in standard form, with standard form, essentially you just need to write your value in a term that is a number that is between 1 and 9.9 and times it by 10 to the power of something. So to turn this into something that is a digit between 1 and 9.9, I'd write that as 1.8, and then I'd multiply that by 10 to the power of, and what I do is I count how many zeros there are before my number starts. So 1, 2, 3, because I'm dividing, it's going to be 10 to the power of -3. Okay, so here I have to add fractions. Now the key thing when adding or subtracting fractions, the key thing is that they need to have the same denominator. Okay, so whenever I am adding or subtracting, the first thing I need to think about is converting the denominators by finding the lowest common multiple of both of my fractions. So 2/5 plus 1/4, I need to think to myself, what is the first number that appears in the times table as a 4 and 5? And if you don't know, then just start out by writing out the times tables. So 4, 8, 12, 16, 20, 24, 28, 5, 10, 15, 20, 25, 30. And you should see a number come up that appears in both. In this case, it is 20. So I want both of my fractions to have a denominator of 20. So I need to think to myself, what have I multiplied 5 by to get to 20? I multiplied it by 4. So to keep the fraction equivalent, I need to multiply the numerator by 4 as well. And 2 times 4 is 8. Then with the other fraction, I do exactly the same. What have I multiplied 4 by to get to 20? I multiplied by 5, so I do the same with the numerator. 1 times 5 is 5. Now that they are both the same denominator, they're both out of the same amount of parts, I just add the numerators together. So 8 plus 5 is 13. So that would be 13 over 20. Now I need to write down the value of 2 to the power of -3. So when I do this, it's actually helpful if we just think about 2 to the power of everything. So let's just write this out. So 2 cubed, that means 2 times 2 times 2 times 2, which is 8. 2 squared means 2 times 2, which is 4. 2 to the power of 1 is 2. 2 to the power of 0. So this is a good one to know. What am I doing each time? Each time it's 1 less power. It means I'm multiplying by 2 1 time less. So each time here I am dividing by 2. So to keep the pattern going, I'm going to have to do 2 divided by 2, which is 1. So then 2 to the power of -1, if I keep the pattern going, 1 divided by 2 is a half, or you could say 0.5. So 2 to the power of -2 would be a half divided by 2, which is a quarter. And then 2 to the power of -3 would be a quarter divided by 2, which is an eighth. What you might notice is 2 cubed is 8, and 2 to the power of -3 is 1 over 8. So this little thing here is another way of saying the reciprocal of 2 cubed. So you might think to yourself, what's 2 cubed? I know that 2 cubed is 8, so therefore 2 to the power of -3 is going to be 1 over 8, which is the reciprocal. Reciprocal just means if you think of your number, so 8, turn it into a fraction. To turn any number into a fraction, you just write it over 1, and then its reciprocal is just flip the numerator and the denominator. So that's how we'd work out negatives. What I would say is probably write it out just to help you spot the pattern if you don't know that it's the reciprocal. Next, I need to write 36 as a product of its prime factors. So I start with 36, and prime factors, it's really good to just recap on the prime numbers. So the prime numbers, essentially a prime number is a number that only has 2 factors, 1 and itself. So that's why 2 is the first prime number, because 1 only has 1 factor, 1 times 1. So 2, 3, 5, 7, 11 are my first prime numbers. So that's what I'm always going to try and divide by. So it's always easiest to start with 2. So if I said 2 times by 18 gives me 36. Now, whenever I get to a prime number, I circle it and that tree branch is extinguished. I then look to 18 and I think of 2 numbers that multiply together to make 18, and ideally one of them is a prime number. Again, 2 is the easiest thing to divide by, so let's do that. 2 times by 9. I've got 2, a prime number. So I'm really baffled as to why my iPad keeps on closing down and restarting, but it did. So, okay, so I've got to 2 times 9. 9, I need to think of 2 numbers. 2 doesn't divide exactly into 9, so I'm going to try the next prime number, which would be 3. And I know that 3 times by 3 makes 9, and both of these are prime numbers. So now I have finished my prime factor tree. So I could write 36 as 2 times by 2 times by 3 times by 3. And that is all I need to do. It hasn't said to simplify it. If it did, you could write it as 2 squared times by 3 squared. But what's really important is it's saying write 36. Okay, so you literally have to say 36 equals as a product. Product means as a multiplication of its prime factors. So its prime factors are 2 times 2 times 3 times 3, because if I actually did that, 2 times 2 is 4, 3 times 3 is 9, and 4 times 9 is 36. So it's just saying, how can I write 36 using only prime numbers? Next, I've got a little fun equation forming question. So with questions like these, when you're given some information but you're not given the exact values, always just the easiest way is to use algebra. There are a lot of people that have done this using trial and improvement. It's just a lot longer. So I'm told that Kiara is 7 years older than Jay. Okay, so I don't know how old Jay is, but I know that however old he is, that Kiara is 7 years older than him. So what I'm going to do is Jay is my patient 0. I'm going to call him X. I don't know how old he is, but I do know that however old he is, Kiara is 7 years older than that. So I can then form an expression. I'm then told that Martha is twice as old as Kiara. So Martha is 2 lots of whatever Kiara is. So Kiara is this expression here. So I'm going to say 2x plus 7. I could expand the brackets just to make my life easier. So 2 times 2, 2 times x is 2x, and 2 times by 7 is 14. So I now have an expression for all of their ages, and I know that the sum, that means add, of their 3 ages is 77. So I know that x plus 7. Okay, so I'm writing out all of the expressions for their ages, plus 2x plus 14 must equal 77. So I've got this nice equation that I have formed, and now I can simplify it. So let's collect all the like terms. So I've got x plus 2x. So that would give me 4x. And then I've got 7 plus 14, which is 21, must equal 77. Now I've simplified this equation. What I want to do is solve it to find the value of x. So once again, I put my finger over x, and then I think, what else is on this side? I've got a positive 21. So I'm going to subtract 21, so it cancels on this side. And whatever I do to one side, I have to do to the other to keep the equations balanced. So I'm left with 4x equals 77, take away 21, 7 take 1 is 6, 7 take 2 is 5. So 4x equals 56. So 4 is being multiplied by x. So what I'm going to have to do to cancel that is divide both sides by 4. So now I have to do 56 divided by 4. 4s into 5 go once, remainder 1, and 4s into 16 go 4. So x is 14. So if I know that x is 14, then let's start with J. I know that the expression for his age was x, so J is just 14. Martha is Kiara is 7 years older, so 14 plus 7 is 21. And, oh my God, I'm writing this all wrong. Sorry, that was Kiara. And then Martha is twice as old as Kiara, so that would be 42. Find the ratio of J's age to Kiara's age to Martha's age. So all I'm going to do is just write out their names. So I've got J to Kiara to Martha. And J is 14, Kiara is 21, and Martha is 42. So the ratio of the ages is 14 to 21 to 42. It hasn't asked me to simplify them, so I don't need to. Next, I've got angles on parallel lines, and I'm told that ABCD is a parallelogram, which means that I've got parallel lines here and here. And you can also identify parallel lines because the little arrow, it tells you that those lines are parallel. So I know that AB is parallel to DC and that AD is parallel to BC. I know that EDC over here is a straight line, so that would be a transversal, which essentially just means a line that cuts through the parallel lines. And F is the point on AD, so that BFE is also a straight line, so this is also going to be a transversal. So I can use all of my angles on parallel lines rules here. I know that this angle here is 35 and this angle here is 75, and I need to show the angle ABF. So ABF is this angle here. You always know, so basically if you don't know how to read the angles, you start from A, you go to B, and then you go to F, so you know it's the angle in between those. So I need to prove that that is 70. So there's a few things that I can do. So using my angle rules, whenever I have like a cross, so over here, hopefully you can see that there's a cross, I know that I can use the vertically opposite angle rule. So vertically opposite angles are equal. Therefore, I know that this angle here must be 35 degrees. Now, the next thing I could do is, if I know that that angle here is 35 degrees, then I know that this angle here, so over here I've got a straight line now, so I've got 35 degrees here, and this angle here form a straight line. So 180 take 35 would give me 5, 4, 1. So that angle here would be 145. I don't actually know if that's helpful yet, but sometimes you work angles out and you don't need them, but it's just helpful to just work out anything that you can. So I'm just trying to think which would be the easiest way. So I could work out this angle here, because when you've got parallel lines, you've got something like this where both angles are on the interior, inside of the parallel lines, and they're on the same side of the transversal, and they are called interior angles. And interior angles add to 180 degrees. So I know that 180 take away 75 would be 10 take 5 is 5, 7 take 7 is 0. So this angle here would be 105 degrees. So that would be a parallelogram. Now, if I turned my, so there's two things. So if you didn't know these rules, then just write them down, but I just need to make some space. So another thing that you should know from your quadrilateral facts is that opposite angles in a parallelogram are equal. So I could have just actually worked that out first. I just wanted to see if there was a route we could do without that. So I could have done that 75 degrees, or if you didn't know that fact, you also know that these two lines here, this line and this line, are parallel. So this angle and this angle here, if you just turn the page around, they would also be co-interior angles, so they would need to sum to 180. So there's two ways you could have got it, either because opposite angles in a parallelogram are equal, or the co-interior angle route. So now I've got this triangle here with an angle of 75, an angle of 35, and a missing angle. And I know that angles in a triangle sum to 180 degrees. So therefore, if I did 75 plus 35, that gives me 10, 8, 9, 10, 11, so 110 degrees. And the missing angle must be 180, take away 110, which is 70 degrees. So all of that working you need to write the reason. So even the basic ones like angles on a straight line add up to 180. Any reason that you use in order to work out the missing angle, just write it down, because for angle reasoning, it's the reasons that they're looking for. So that's how we show that this would be 70 degrees. The final bit is angles in a triangle. Over here now, I've got a diagram that shows a logo made from 3 circles, and each circle has center O. Daisy says that exactly 1/3 of the logo is shaded. Is she correct? Okay, so this is a little bit of a tricky one for non-calculator, but what do we do? So first of all, if I'm dealing with circles, it's just helpful to write out the formula. So the formula for the area of a circle is pi r squared, where r is the radius. Is this non-calculator? It must be. Okay, so yeah, so it's just going to be a little bit tricky, and we're going to have to work with pi. So hopefully you're comfortable with working with pi. So I've got the small circle, which is here, and that has a radius of 4. So I'm going to do pi times by 4 squared. 4 squared is 16, so that would simplify to 16 pi. Then I need to work out the area of the larger circle, the middle one. So the middle circle is pi times by, and it's going to have this whole radius, so that's going to be 7 squared, which is 49 pi. And then finally I need the area of the largest circle, so that's going to have a radius of 4 plus 3 plus 3. 4 plus 3 plus 3 is 10, so the large circle has an area of pi times 10 squared, which is 100 pi. Now to work out the shaded area, so this part here, essentially what I need to do is work out, so with shaded area you always work out the area of the big thing, and then there's going to be like a little thing that is taken out of that. So the shaded area is essentially, oh no, that's not what, okay, so sorry, I misread the question. So the shaded area is going to be the area of the whole pink circle. So imagine all of this, but the small circle has been taken out of it. So you work out the area of the middle circle, which is 49 pi, and you subtract the area of the small circle, which we worked out to be 16 pi. And that's going to tell you what the shaded area is. So the shaded area is going to be 49, take away 16, 9 take 6 is 3, 4 take 1 is 3, so that's going to be 33 pi. And remember that when we're working with pi, we can treat it like algebra, so it's like saying 49x take away 16x. So the shaded area is 33 pi. She says exactly 1/3 of the logo is shaded, so the total area of the logo is 100 pi. The shaded area is 33 pi. So essentially what I need to do is see whether 33 pi over 100 pi is equal to 1/3. So 33 pi divided by 100 pi. What I can do first is cancel out the pi. Whenever you've got a fraction and the numerator and the denominator are both products, which means everything is being multiplied, anything that's the same on the numerator and the denominator cancels out. Pi divided by pi is just 1. So that's the same as 33 over 100. And 33 over 100, if I turned it into, well, actually, there's 2 ways I could go about this. So 33 over 100, I can't simplify that anymore. So let's just turn it into a decimal. So that would be 0.33 exactly. Whereas 1/3, this is something that we kind of need to know. We need to know our some of our basic fractions. So 1/3 is 0.3 recurring, which is 0.333333 going on for until eternity. So Daisy is not correct. She is very close, but only 0.33 of the shape is shaded, whereas a third is 0.3 recurring, which is slightly larger. So it's quite a tricky question, but there's lots of marks that could be picked up along the way. Okay, so next it says the table shows information about the weekly earnings of 20 people who work in a shop. Work out an estimate for the mean of the weekly earnings. Now, the reason we say an estimate is because with these questions, we always have a range. So here we know that one person has a weekly earning of between 150 and 250 pounds, but we don't know the exact value. So what we do, if we ever have to work out the mean from a grouped frequency table, the first step is that we want to work out the midpoint of our class intervals. So I'm just going to write a little column, a little thing for the midpoint. So I want to work out halfway between 150 and 250, which is 200. If you didn't know how to work out the midpoint, you just add the two values together. So 150 plus 250, and then you divide by 2. So 150 plus 200 plus 200 is 300, 50 plus 50 is 400, so that would be 400 divided by 2. So you can do it that way, or you might just be able to look at it and find the midpoint. So the midpoint here would be 300, 400, 500 and 600. So that's step one. Then what I do, now that I have found my midpoint, in my final column, oops, I did the times is in the wrong place. In my final column, what I can call this column is the midpoint times by the frequency. So what I do is I multiply my frequency by my midpoint. So 1 times 200 is 200, 11 times 300, so 11 times 3 is 33, so 11 times 30 would be 330, and 11 times 300 would be 3,300. So we can do it like that. 5 times 400, so let's do it the same way. 5 times 4 is 20, times by 10 is 200, times by 10 again is 2,000. Or you could just do 5 times 4, which is 20, and then add on the 2 zeros. So that's 2,000. 0 times 500 is 0 times by anything is always going to be 0. Because if no people earn between 450 and if no people earn £500, then no money is earned. And then 3 times 600, so 3 times 6 is 18, and then add the 2 zeros, so 1,800. So once you've done this column, to work out the mean, what we do is we add up the value of all of this final column, because what I've done is I've essentially said, okay, 11 people earn £300, so in total 3,300 pounds has been earned. So I add up the total money earned. So the mean is going to be the total of your midpoint times frequency column divided by the frequency. And the frequency is always going to be your second column, and you are actually told what the frequency is. The frequency means that it's always in context. In this question, it would be the number of people, but it might be the number of points scored or whatever. Frequency just means the total amount. So I know that this total over here is 20, and all I need to do is work out what this total here would be. So let's add everything together. I'll just start with the largest numbers and put them in order of size. So I'm adding 3,300 plus 2,000 plus 1,800 plus 200. So 0 plus 0 plus 0 is 0, 0. 8 plus 2 is 10, plus 3 is 13. 3 plus 2 is 5, 6, 7. So the total is 7,300, and I'm going to divide that by 20 because that is the frequency. So what I can do now is just simplify my fraction. So if I divide by 10, that would be 730 divided by 2. And because I've simplified it to a nice little fraction now, what I can do is just use the bus stop method to help me out. So 730, that total was here, divided by 2. 2's into 7 go 3 times, remainder 1. 2's into 13 go 6 times, remainder 1. And 2's into 10 go 5. So an estimate for the mean of the weekly earnings is 365. You can always sense check your answer as well, because if, like, for instance, your answer was £3,650, does that make sense? The mean is like the average, and nobody earns more than £650 per week. So you know that 3,600 is way off. Similarly, if you maybe accidentally got £36.50, does that make sense? Because the lowest anyone earns is 150. So always double check your answers just by using common sense. Okay, so now I'm being told that Nadia says that the mean may not be the best average to use to represent this information. So you've got 3 averages. You've got your mode, your median, and your mean. So the mean, she's saying, might not be the best average. So I need to think, what would the other 2 averages offer me, and what is that doing? So when I have the mean, I'm essentially adding all the scores together and dividing by the total number. So it gives me like an average. But if I have all of my data skewed to one end of the spectrum, then it skews the data quite a lot. So as you can see over here, 11 out of the 20 people, so that's over half, earn less than £350. And they said that the average is £365. So if 11 people are earning, let's say, £255, that's inflating their wage. So what can the other averages offer me? Well, the mode is the most common. So if I use the mode, that would say that the average weekly wage is between 250 and 350. Or I could use the median. So if I use the median, then I've got one person, which is over here. To work out the median, what you do is you have your frequency, which is 20. You add 1 and then you divide by 2. So 21 divided by 2 is 10.5. So the 10.5 value would tell you the median. And the 10.5 value would land in this interval here. So both the mode and the median tell me, both the mode and median suggest that the average wage is between 250 and 350 pounds, which is less than what the mean suggests. The mean takes into account all of the values, and so can skew the data. In this case, it's inflated it because there's 3 people that earn potentially £650. So that makes it seem like everyone in the company is earning more. Next, I've got a rectangle. It has a width of y and then a length of 2x plus 6, which is the equivalent to 5x minus 9, because in a rectangle, opposite sides are equal. Okay, so I'm told that all measurements are in centimetres, and the area of the rectangle is 48 centimetres squared. Show that y is 3. Okay, so there's a few things that I can do. First of all, what I can do is figure out what the value of x is. And I can do this because I know that this side is equal to this side. So I can set up an equation for myself. I know that 2x plus 6 must be equal to 5x minus 9, as they are both opposite sides of the same rectangle. So it's a little bit of a tricky equation to rearrange because I've got x variables on both sides. And when this happens, just subtract the smaller variable from both sides. So I'm going to take 2x because that will cancel it out here. And I have to do the same to this side to keep the equations balanced. So that would give me 6 equals 3x take 9. And now I've just got a normal solving equation. So I do what I'd normally do, cover up the x. What is left? A -9. So I'm going to add 9 to both sides. So 6 plus 9 is 15. So 15 is equal to 3x. And if 3x equals 15, the next part would be to divide both sides by 3, because 3 is being multiplied by x. So that cancels over here. And I'm left with x equals 5. So I know that this side and this side have a length of 5. Now, I'm also told that the area is 48 centimeters squared. So I know that 5 times by y must equal 48. So if 5y equals 48, oh, sorry. This is why you need to read the question very, very carefully. So of course, the side does not equal 5. I've worked out what what x equals. So now I substitute it back into the expressions for the sides. So if x is 5, 2x is going to be 10. 10 plus 6 is 16. Let's double check if that works for this side as well. If x is 5, 5 times 5 is 25. 25 take away 9 is 16. That makes a lot more sense. So that means that 16 times by y is 48. So 16y is 48. So to figure out what y is, I'm going to need to divide by 16. Divide both sides by 16. So y is 48 over 16. So I've got a fraction here. To show this division, I can just simplify the fraction. So let's start by dividing by 2. So 48 divided by 2 is 24. 16 divided by 2 is 8. I can divide by 2 again if I don't quite know what this is. 24 divided by 2 is 12. 8 divided by 2 is 4. If you can't see that 12 over 4 is 3, that's fine. Divide by 2 again. So that would give you 6 over 2. And 6 over 2 equals 3. So if you've shown all of this calculation, you show that y equals 3, because 3 times 16 makes 48. Over here, we now have Brogan needs to draw the graph of y equals x squared plus 1. So every quadratic graph, it should look something like this, okay? Or it might be upside down. But the point is that with a quadratic curve, it's a mirror reflection of itself, and you always draw it freehand. So the thing that is wrong with Brogan's graph is he has not drawn freehand. The graph should be curved. So what has he done wrong? He's joined the points together with a straight line when they should have been joined like this. Okay, so whenever you draw a quadratic graph, you always join the points with a smooth curve. In a sale, the normal price of a book is reduced by 30%. Okay, so if the normal price is 100% and it's reduced by 30%, that means that the sale price is 70%. Okay, so the sale price of a book is £2.80. So I know that 70% is equal to £2.80. Now, what I want to do is work out the normal price of the book. So this is a reverse percentages question. And what I want to do is just work out something nice and easy for myself. So I could just work out what 10% is. So what have I done to get from 70% to 10%? I have divided by 7. So I need to do the same to this side. So £2.80 divided by 7. 7's into 2 you can't do, so you carry the 2. 7's into 28 are 4. 7's into 0 are 0. So 10% is £0.40, or you could have written 40 pence. And then I can get back to 100%. So what do? I multiply 10% times by 10 gets me 100%. So I do the same to this side. And 40 pence times by times by 10 is £4. So the normal price of the book is £4.